Okay, so it says the continuous function f, and the word continuous is sometimes important. Key to recognize the word f. It's defined on this interval. Key to go slow enough that I recognize this is f, not f prime. The graph of f consists of two quarter circles. So quarter circle, one line segment. This formula will for sure be important. This is not showing up very well, but this is a plus. Okay. Find g of negative 3. Well, I have a formula for g. So g of negative 3 must equal the 2 times the x value is negative 3 plus the integral from 0 to negative 3. Now, if for some reason you're, if I can just pause the video and check something. Okay, I was just making sure that the plus was very visible on the PDF file, and it is, so we're good there. Okay, this integral is backwards, so I want to switch this. So this will become negative 6 plus negative 1 multiplied by negative 3 to 0 of f of t dt. Don't forget the dt. So negative 6 plus negative 1 multiplied by. So I'm integrating from negative 3 to 0. So negative 3 to 0. For that integral, every value of f is positive. Therefore, all of this area will count as a positive number. It's a quarter circle. So circle is pi r squared. And we're 1/2 of that circle, sorry, 1/4 of that circle. Okay, no simplification is required. The radius of that circle is 3. You can stop right there. And that will get you full credit. You don't need to do anything else for finding g of negative 3. And as long as you got to this line, you can't stop sooner, as long as you got to here, this value here, for g of negative 3, you have to make sure you have the equal sign over here, so that they know it's g of negative 3, but that's 1 point. Okay, now they're asking us to find g prime of x. So we have a formula for g. So I'll copy this over to get a little more space. So, let's see, delete this. So to find the derivative of this formula, we're going to have g prime of x. The derivative of this would be 2, plus, to find the derivative of an integral, we'll use this formula. So f is f, the upper limit is x, lower limit is 0. So I'm going to get, pull this out of the way, f, just back up. So I get f, right then. So I get f of the upper limit, which is x, and then d over dx, because I'm taking the derivative of g, whose input variable is x. This would become x minus f of the lower limit, d of the lower limit. This This is 0, so this is 0, this is 1. So I have figured out that g prime of x is equal to 2 plus f. If I get that far, you don't have to have a box. I'm just using the box to hopefully make it clear what you get the point for. 1 point for doing that. Then it says find g prime of -3, so we plug it in. So we say g prime -3 must equal 2 plus f of -3. Can't stop there because we've got to find what f of -3 is equal to. Oh, that's a 0. So g prime of -3 has a value of 2. Again, you don't have to have the box. That's just to hopefully clarify what you're getting the point for.